Yeah. Good morning, students. Are you hear me? Is it audible?
Yes, sir.
Yeah. Okay. So, yeah. Very good morning. What we have discussed in the last class? Where we stopped the last class? Is source transformation is over, and examples for the source transformation. I think we are discussing this problem. Is the screen is visible? That presentation
Yes,
is that problem given in the last class. Is it visible?
sir.
Yeah. Yeah. So did you finish that problem? Anyone got the answer for the loop currents? Yes, yes. Please respond quickly. Did you solve the problem or not? I have given the equations, the related equations I2 minus I1, I2 minus I4, I3. So you can convert by using these relations. The one KVL equation already we have written. So we can convert this equation into, so this equation 1 into an equation of single variable, that I1. So I got the answer as I1 14.65 amperes. I1. Is anybody got that answer? Solved this one for I1. So by simplifying, here voltage is 10 volts is there, 30. So 40 volts minus I1 terms is 1 I1 minus 10 I1. So minus 11 I1. I2 terms, one more 20 volts is also there. So 30 plus 20, 50 plus 10, 60. 60 volts minus 11 I1. I2 terms, only one I2, that is minus 4 I2. I3 plus 20 I3 plus 10 I3. So 30 I3. I4 minus 8 I4 minus 20. So minus 28 I4 is equals to 0. I3 we have 15. So 30 into 15, 450. Right? 450 plus 60. 510 minus 11 I1 minus 4 I2 minus 28 I4 is equals to 0. From this equation, I2 minus I4 equals to 10 amperes. I4 is I2 minus 10. I4 is nothing but I2 minus 10. So 510 minus 11 I1 minus 4 I2 minus 28 I2 plus 280. Right? 510 plus 280, 790 minus 11 I1 minus 32 I2 is equals to 0. From this relation, I2 minus I1 equals to 5 amperes. I2 is I1 plus 5. Right? I2 is equals to I1 plus 5 is 790 minus 11 I1 minus 32. So 32 plus 11 minus 43 I1 minus 32 into 5, 32 5s. Find out what is 32 5s. Are you following? 32 5s are 160. Minus 160 is equals to 790. So 790 minus 160. 790 minus 160 is 630. So minus 43 I1 is equals to minus 630. So I1 is 630 by 43. 630 divided by 43, that is 14.65. 14.65 amperes I1. So from this you can find the remaining values. We have the relations already I3. So we got as a 15 amperes. So you can find out the remaining values, right? Is it clear? Is it clear for everyone? Shall we move to the new topic, the next one? Respond please. Yes. Okay. Have you noted down this? I1 is 14.65 amperes. So next we will go to the next concept of our network analysis, that is graph theory. It's called network topology, or the other name for this one is the graph theory. So this is very easy to understand, and so this is another way to analyze the network. So without concerning the elements, what are the elements? That means whether it consists of dependent sources or independent sources, active or passive elements, whatever it may be. So we can write the KVL and KCL equations simply by converting the network into a graph. Okay, so that is the advantage of this graph theory. It is called network. Note down the topic name. It is known as network topology, or graph theory. See, that means if you take any network which consists of elements like passive elements or active elements, or dependent or independent sources, so all the networks must satisfy KCL and KVL, right? So that means the algebraic sum of all the voltages in a loop must be 0. Similarly, if you apply the KCL at any node, sum of the currents entering towards the node must be equals to the sum of leaving currents. So for any network, these two laws should be satisfied, irrespective of the elements that are present in the network. So, but to analyze this one, if the different elements are present, that means voltage sources or resistors, inductor, we need to write the different voltage relationships. So, but by converting the network into a graph, so we can write these equations very easily and we can analyze. So that is the advantage of the graph theory. So now let us see what is a graph at all. Suppose if I take one network, I am taking one network as an example, which consists of different elements, not only one type of elements. So it is having different elements. Note down this one. Put the heading as graph theory. And this is very easy to understand. If you concentrate on this, it is very easy. So I am giving the names for the elements as A, B, C, D, E, F, right? Okay, so this is the network given, the given network. So how many nodes are there in the network? How many nodes are there in this network?
3.
Only 3? Please check the network again. Please check the network again.
4,
How
sir.
many? 4. Yes, this is 1. Give the names also. This is 2, 3, and 4. Right? So 4 nodes. This network is having 4 nodes. So graph is nothing but writing the, irrespective of the elements, so writing a line segments that is interconnecting the different nodes. So simply writing interconnection between. So see, how many nodes are there? I am writing the, indicating the nodes here. This is the node 1, this is node 2, this is 3, and this is 4. I am writing each branch as a line segment, each branch. So there is a connection from 1 to 4 irrespective of the elements. This is 1 to 4, one connection, and 1 to 3, there is one more, 1 to 2, and 2 to 4. 2 to 4 is there, 2 to 3, 3 to 4, right? So this is called the graph of the given network. Graph of a given network. Is it simple or not? Simply writing the, first indicate whatever the nodes that are present in the network, write the different branches. So these are called the branches of this graph, branches of the network. And here there is no direction is indicated. Is there any direction? No. So it is called an undirected graph. That means there is no direction. Suppose if current direction is given, suppose if I indicated the current direction like this, currents also. Okay. And I am writing the currents names as IA, ID, this is IE, IF, IC, IB. Where the elements, here it is a branch, name is A, here this is D, this is F, E, C, and B. So branch names. So including the current directions, if current directions are also given, this is called a directed graph. Okay. So what we have written here, simply we replaced our network with the given nodes, whatever the nodes that are given on in the original network, and the different interconnections between the nodes. So that means nothing but the branches. So how many branches are there in this network? How many branches? Yes, how many branches are there? Branches are given with the numbers, letters A, B, C, D, E, and F. How many? 6 branches. This is denoted with B, 6 branches. Nodes are indicated with N. N is the number of nodes are 4. N equals to 4 and B is equals to 6. Okay. So the network is like this. The representation of the network with the line segments with the different nodes is given as the graph. So if the current directions are also indicated here, it is called the directed graph. Okay. So it is called a directed graph. So we will use this graph because it is simple. Here no elements are given. So simply the branches and its direction. Suppose if current direction is given, its directions are given. Okay. So branches are represented with B and nodes are denoted with a N. So in this particular network and its corresponding graph, if you see the corresponding graph, particularly it is called a directed graph. What is the directed graph? What is the directed graph? Directed graph means if current directions, if the directions are indicated in the graph, current directions are indicated, so it is called a directed graph. Otherwise it is undirected, right? So two fundamental things here we need to know is the what is a node what is a node and what is a branch. So here these are the nodes. Nodes are nothing but interconnection of two or more branches. Branch is a line segment that is drawn between any two nodes is called a branch. Right? Is the two things are clear? Branch and node. Graph, we have seen four unknowns here, four terms, graph, and in the directed graph, nodes of the graph and branches of the graph. Is it clear? Are you following?
Yes, sir.
Yeah, now we'll see what is a tree. What is a tree? So tree is nothing but a subgraph. So this is the graph. Actually, we have seen this is the graph of a network. The subgraph, that means which consists of all the nodes of this graph, but there should not be any closed loop. There should not be any closed loop. So it should be, that means a tree must contain all the nodes that are present in a graph, but not the closed loops. Okay, that means how many nodes are there here in the given network or for a graph? Any node, how many nodes? 4 nodes. 1, 2, 3, and 4. So there are four nodes are there. So the tree must contain all the nodes of the graph, nodes in the graph, but there should not be any closed path between any two nodes. So how to write this one? That means number of branches may be different. Number of branches are always less than that a graph can have. So that means if I write like this, suppose this is the node 2. Node 2 here. There should not be closed path. And what is the name of this branch? Branch is A. I am writing the branch name as A. And one more branch. This is C. And one more is B. This is B. Right? All the nodes are there. Whatever the nodes that are present in the original graph are there. That means 1, 2, 3, and 4. But there should not be any closed path. Is there any closed path in this one? There is no closed path. So this is called a tree of the graph. So one graph may have any number of trees. Here I have written a tree in terms of ACB with the branches ACB and is one tree. So can you tell me one more tree for this graph? Tree means tree is a sub-branch, subgraph. T is nothing but a subgraph which consists of all the nodes that are present in the original graph, our actual graph, but no closed loop, with no closed loop. Can you tell me any branches with which is branches of the tree? Because one graph may have any number of trees. Can you tell me? Here I have written one, this one ACB. Here I have written ACB. Suppose, see again I am representing one more. It should have all the nodes 1, 2, 3, 4. 1, 2, 3, 4. Can you write one more? A. This is D. And E. This is also a tree because it is not having any closed loops. Not having a closed loop. Right? A, D, E with ADE, the branches ADE forms a tree. Likewise, ACB, this is also one tree. Can anyone tell me one more tree for this network or graph?
CDE.
CDE. CDE, right. CDE is one more. This is C. One tree. One more. Anyone? One more graph. Anyone from the class? One more. Can we write this one to this FBC? FBC. Is it a graph? Sorry, is it a tree? FBC. One, two, three, four again. F is this one. B. This is C. Right? Is it a tree or not? There is no closed path. Right? CEF. CEF, right? CEF is also a tree. Okay, so write that. We can write any number of trees for a given network, right? For a given network, for a given graph. So the removed branches, whatever the removed branches are called the other branches. That means for any tree. See, suppose if you write this tree, first one, whatever we have, what are the removed branches here? D, E, and F. A, C, B is there. The removed branches are, this is D, this is E, and this is F. So these removed branches are called links. Okay, that means links are defined for a tree. So in a tree, so without having closed loop, if you write any number of branches like this, the other name for these branches of a tree are called twigs. Twigs. And the remaining loops, the remaining branches which forms the closed loop are called the links. Twigs and links are the two names, right? So for a given tree, if there is a tree is given, that means if for a network, we can draw the branch, we can draw the graph for a network, and if it is current directions are indicated, it is called a directed graph. So for a directed graph, if we draw a subgraph which consists of all the nodes, whatever the nodes that are present in our original graph. So, but there is no closed loop. So, that is called a tree. That is called a tree. in the tree, the branches of tree are called twigs. Twigs and the remaining branch, that means the removed branches in a tree. That means by adding these branches, a closed loop is formed. Suppose for any tree, if we add one, if you draw a tree for a graph, and in a tree, if you add one branch which forms a closed loop, if that forms a closed loop, so that kind of branch is called a link. Okay, so tree means set of branches which consist of all the nodes but no closed loops. Okay, the set of all the links, set of all links. What are the links? Links means the branches which forms a closed loop for a tree, right? Tree means, what is a tree here? We have formed a tree from the graph, right? Because which consists of all the nodes but no closed loops. That is a tree. The removed branches of tree are called, for any tree, there are some branches are removed. Those are called the links. Links, okay. Set of all the links, whatever the links are there, set of all the links are called co-tree. Co-tree of a branch, right? Set of all the links is called a co-tree. Tree and co-tree, these two are called the complementary branches. Okay, so these two doesn't have any intersection. For a given tree, the twigs are set of the branches of the tree, and links are the branches by adding which forms a closed loop are called the links. So here, suppose if you see in the first example, A, C and B, these are the branches of a tree, or these are called twigs. For this tree, the branches D, E and F, these three are called the links, right? Is it clear? That means by adding a link, that means by adding one link, so there is a, so we can, there is a current, closed path. Since the closed path exists, so there is a loop current. There exists a loop current in the network, right? That means if you see the first diagram, that means this is the example for the tree. What are the branches of the actual tree? The branches in this tree are, in the first example, the branches of this particular tree are A, C, B. A, C, B are the branches of tree. D, E, F, these are called the links, are branches of co-tree. The set of all the links is called the co-tree. So by adding one link, a closed path will be formed and there will be a current. Closed path means there is a loop current will be existed. So that means the number of loop currents that exist in a tree are equals to the number of links. That means suppose if we add D, there is one current. Let us assume this is I1. Suppose if we add E, one more current, you will get one more current, that is I2. And if we add third link, that is F, we will get one more current, I3. So number of links for any tree, if you draw a tree, each addition of each links forms a closed path. That means one loop current will be existed for each link. Okay, so from this, the first analysis we can made is we can form a matrix, so which gives the information about the graph is called incident matrix. Will the first form a matrix which is denoted as A, incident matrix. The size of the incident matrix, the incident matrix size is N by B. N by B. What is N here? What is N? For a graph or for a graph, what is N?
Nodes.
N is
Nodes.
Number of nodes. B is
Branches.
Number of branches. So the incident matrix size is N by B. That means nodes, number of rows is equals to number of nodes. That means for this graph, So number of rows. What is the size of incident matrix? 4 by 6, right? 4 by 6. There are 6 branches, A, B, C, D, E, F. So 6 branches, 1, 2, 3, 4 are the nodes. So 4 by 6 is the incident matrix size. So incident matrix entries. Suppose if you write one entry of incident matrix, A, I, J. So where the first suffix I represent the node, ith node, and second suffix J represents the branch, right? I represents node, J represents a branch. So that means if you write A11, the first element of the incident matrix, A11, that means first suffix represents a node, second suffix represents a branch. So there are 3 kind of entries in a incident matrix. That means Aij, if it is equals to +1, one entry is called the +1. So we'll write +1 means if the jth branch, J represents the second suffix represents the branch. Jth branch is on node I, ith node. That means we can say this is called, why it is called incident means, see here node 1, if you take node 1 in this diagram, so branch A is said to be incident on node 1 because it is connected to the node 1. So it is said to be incident on node 1. Similarly, branch C. C is also incident on node 1 as well as B. B is also incident. But here the directions, the direction of current is moving, it is moving away from, that means it is, we can say incident, and it is moving, the direction of this branch is away from the node 1. Like incident means it is connected. See here, suppose if you see the node 2, what are the incident branches on node 2? What are the incident branches on node 2? A, D and F. A, D and F are the incident branches, right? So like this, that is called the incidents. So Aij is equals to 1 means, if entry is 1 means, we will write the entry in the incident matrix as 1 if the jth branch is incident on node I, on ith node, and oriented away from ith node, and its orientation is away, moving away from I, node I, then we will say the entry is 1. Suppose if it is moving towards I, we will write this as -1. That means incident matrix will have 3 entries. One is a +1, another one is -1, third one is 0. Okay. So Aij, as we have discussed here, Aij is equals to 1 means jth branch is incident on ith node and moving away from the node I. Suppose the jth branch is moving towards node I, means it is -1. There is no incidence means 0. So there are 3 entries in the incident matrix. Suppose I will give you a simple graph to understand what is the incident matrix and how to write the incident matrix for a given graph or given tree. Let us see here. One, I will give simple graph. So which is having 4 branches and 3 nodes. Simple one. 1, 2, 3. 3 nodes and 4 branches. 1, A, B, C and D. Okay. So what is the size of incident matrix for this graph? How many nodes are there? Nodes are 3. Yes. Branches are 4. A, B, C, D. Right? So now our incident matrix A is having, what are the rows for this one? Rows are the nodes n by b. Columns are branches A, B, C, D. Right? So first entry, let us see at node 1. Okay, what are the branches incident on node 1?
AB.
A and B. A, B are the incident on node 1. But what is the direction? A is leaving from A, 1, node 1. So leaving means its value is +1. A is leaving from, yes or no? A is leaving from the node A, node 1. Okay. So what about B? B is also leaving,
+1.
right? B is also leaving from the node 1. What about C and D? Is there any incidence of C and D on node 1?
No, sir.
So 0 and 0. Next, see, if you see the node 2, at node 2, what are the incident branches? A, C and D. A is approaching towards 2. So -1. Entry for A is 1 because it is moving towards 2, right? C, D. B is incident on 2? No. B is not incidenting on 2, so it is 0. C, what about C? C is moving away. D is also moving away, right? Moving away means, we have discussed any entry Aij means jth branch, that means here branch A1A, the first element we will call A1A, that means branch A is incident on node 1 and moving away from node 1 means +1, right? Like this, we need to write the for every node. What about node 3? What are the branches
BCD.
incident on BCD? All are moving BCD. All are moving towards the node 3 and there is no incident on node A, right? So this is called the incidence matrix for the given graph. So what you have observed from some features you can observe from this graph, from this incidence matrix. That means incidence matrix will give you the clear information about the graph. That means if incidence matrix is given, you can draw the graph also. Yes or no? So if you observe the columns of the incidence matrix, each column, what you can observe from each column of the incidence matrix? What property you have observed? Yes. Each column has 2 entries. What are the 2 entries?
+1 -1.
Each column has 2 entries. One is +1 and one is -1, right? Each column, if you observe the columns, first column is +1 and -1, second column also, third, fourth. If you observe every column, there is one +1 and one -1 is there. +1 entry is there, -1 entry. So what this indicates? Each column means it is related to a branch. That means branch means it should be starting from one node and it should ends on another node. Okay, in a directed graph, if it is a directed graph, it should start from one node and ends on the other node, and the direction, the direction is given. So if you see any random branch, that means C, let us take C. C is having +1 at node 2. That means it is leaving from node 2 and -1 approaching towards node 3. That means branch C lies between two nodes, that is node 2 and node 3, and direction is given by the sign. +1 means it is moving away from node 2 and moving towards the node 3. Similarly, if you see the branch B, what is the +1? Where it starts? Branch B starts from node 1 and it ends on, it incidents, that means it approaches towards the node 3. So that's what each column is given. So columns gives the information about the branches and its direction. And if you observe the rows, what about the rows? So row gives the number of branches incident, that means related to each node. That means if you see node 3, so it shows 3 entries. Node 3 has 3 entries. What are the 3 entries? B, C, D. Node 3 has 3 entries, B, C, D, right? B, C, D. But all are -1. -1 means 3 branches are approaches towards 3, right? Node 3. So that means this is called degree of the node. The number of branches incident on a node, or in an incidence matrix, the number of entries for each row is known as a degree of the node. Degree means the number of branches incident on a particular node are known as a degree for a node, any node, right? So now write the incidence matrix for this one, the above graph, already what we have discussed. This one. Is it clear? Shall I write again? Write the incidence matrix. So how many nodes are there here? How many nodes?
4.
4 nodes. And each is given as with the names also. A, direction B, C, D, E, and F. So branches, how many branches? Nodes are 4. 1, 2, 3, 4. Branches are 6. A, B, C, D, E, F. So incidence matrix is a 4/6 matrix. It is a 4/6 matrix. Rows are 1, 2, 3, 4. Columns are A, B, C, D, E, F. Right? So write the incidence matrix for this. First, for node A, that means entries of first row. How many branches are incident on node A? Node 1. A,
3.
what are those? 3. A, B,
C.
C. A, B, C. All are leaving. right? All are leaving. So the first row entries are A, B, C. So first row consists of +1 plus A for A, B and C. All are +1 only, right? 3 nodes are incident on the first 3. What about second one? Node 2. Node 2. How many branches are incident on node 2? Node 2. How many branches?
3.
Again 3. What are those 3? A,
DF.
D, F. But here A is moving towards the node 2. So what is the entry for
Minus.
A?
-1.
-1. D +1. F is also +1. Right? Remaining are zeros. Next, node 3. At node 3. See how many entries are there at node 3? Incidents. What is the degree of node 3? What is the degree of node 3? What is meant by degree? Degree of a node? Degree of a node means number of branches incident on that node, right? Number of branches incident on the node. So, how many branches are incident here?
2.
3.
3. Please check once again.
2, sir.
Node 3. Node 3. C is approaching. D is approaching. E is leaving. 3. Right? C is approaching means -1. D is approaching -1. What about E?
+1.
E is leaving. So remaining entries are zeros. 4. Node 4. Is A is incident on node 4?
No,
No.
sir.
So 0. Is B is incident on node 4?
Sir.
Yes, sir.
Yes, it is approaching. So what is the entry here? -1.
-1.
Yeah. C? No. So it is 0. D?
0.
0. E?
-1.
Approaching. So
-1.
-1. F?
-1.
-1.
Approaching towards -1. So you can cross check. Each column is having 1 plus and -1 entry are there or not. Okay. So it is simple to, you can cross check this incident matrix whether whatever you have written is right or not, right? So each column must have 1 plus entry and 1 minus entry, right? Now one more graph. Nodes are given as A, B, C, D. The branches. 1, 2, this is 3, 4, 5, and 6. So this is the given graph. So for this, you write the possible trees, all possible trees, and write incidence matrix. What is a tree? What is the definition for tree?
Open circuit.
Open circuit. Is it enough? Open circuit. Tree is a sub branch of subgraph. Tree is a subgraph which consists of all the nodes, but doesn't have any closed loop, right? Sai Kiran, right? He given the definition. That means subgraph with no closed loops. That means only open loops are there. So you write the possible, whatever the possible trees, how many trees are possible as you can. Okay, you write the possible, all the possible trees and incidence matrix for this one, right? In the next class I will check with you. So everybody should come with your whatever possible trees you have written for this. I will ask everyone whether you have written or not. Okay, incidence matrix should be written. Everybody should attempt this problem. We have to write all possible trees for this given graph and note down this one, all the possible trees and incidence matrix, right? Okay, so don't leave the class. I will take the attendance now. It's 4 C
Present, sir.
7 C8
Present, sir. C8.
C9
C name present, sir.